In this class, we're going to take a look at how you write the equation of a straight line. So remember that the equation of a straight line captures two things. It captures the slope or the gradient of the line, and it captures the y-intercept, so where the line cuts over the y-axis. When you're writing the equation of a line, sometimes you want to write it entirely accurately. That's the question. The question is, here's some information, what is the equation of this line? And we're going to look at that in this case, but sometimes you just want to estimate the equation of a line, just to get a feel for what it might be as part of maybe a bigger question where you just need to get a sense for whether the line has got a certain equation type. And we'll look at that over in this example here. So to start maybe with this one here, if you've got access to a sketch like this one here, then that already gives you information about the line. So we know that because this red line is sloping down the way to the right, it's got a negative gradient, so that needs to come out in the algebra. If we end up somehow with a positive gradient, then something's gone wrong. So that's one thing about that. Also, in this case, we can just read off the y-intercept. So we know that the y-intercept should come out to be 4. So we know the y-intercept, so that's fine. Remember, what we're trying to do here is to put it in the format of equation y equals mx plus c, where m is the gradient and c is the y-intercept. So we already know that our c value is going to come out to be 4 in this case. So we just really need to find the gradient for this one and we're done. So remember, the gradient formula is the vertical divided by the horizontal, or if you're used to doing it by points, then you would need the full coordinates for these points. So 2, 0, and this point here is 0, 4. And usually in that format, we label these x1, y1, and x2, y2, or some variation on that. There's different ways to label these in different forms of this equation, but for finding the slope, the gradient, is essentially the difference in the y, which is the vertical, divided by the difference in the horizontal, and that is how we find the gradient. So the gradient in this case is going to be 4 minus 0 divided by 0 minus 2. Okay, and be careful with that because it's 4 minus 0, so we started here and took away from here, and then we have to start here and take away from here. That's going to give us a negative number, which then makes the gradient negative, which is what it should be. So 4 minus 0 is 4, 0 minus 2 is negative 2, so that comes out to be negative 2. So we know that the m value is negative 2, so the equation of that line, y equals negative 2x plus 4. And that all fits in with the geometry, so we're happy. That's how it works for that one. Okay, so this time we don't have a visual. It's quite a good idea if you don't have a visual just to go ahead and create one real quick, just for reference. Because we're going to do this one more algebraically, but because we're doing it algebraically, we don't have a visual self-check mechanism like we did with that one. So if you plot on the points, 4, 3, so 4 along, 3 up, that's going to be roughly there. It doesn't have to be entirely accurate with this, just to get a sense for things. And then 2 along, that's halfway to 4, so that should be there. Negative 6, that should be twice as far down as that one was up. So that's going to be there. Okay, and then if you put our, maybe need to extend the y-axis here a little. And then if we put a red line going through these points, roughly, like that. So we can see this time the line's quite steep and going in the other direction. So it's going up to the right, so it should be a positive gradient and probably greater than 1. The gradient should come out to be greater than 1 because a 45-degree line is a gradient of 1. So we're looking here at a gradient of at least 2, probably more than 2. And also the y-intercept is quite far down the way. This point here has got a y value of negative 6. So we're looking at maybe almost double that, maybe minus 12, somewhere around about that kind of number. If this comes out to be some number nowhere near minus 12, if it's like a positive number or minus 100, then something's gone horribly wrong. So just checking this one out, let's start by the gradient. So we could just label up the points in the way we did over here. So this is our x1 and our y1, and this is our x2 and our y2, or some variation that you use personally of that formula. So the gradient would be, let's go for negative 6, we'll start with that one, minus 3. It doesn't matter which way around you do it. So I'm starting with this one, and then it would be 2 minus 4. So minus 6 minus 3 is negative 9 over 2 minus 4 is negative 2. The negatives would cancel. 9 over 2 is 4.5. So that's perfect. So it's come out to be a positive number. We expected it to be a number bigger than 1 because it's a steep line, so 4.5 fits in really well with the geometry. So different ways you can finish this one off. You can just, for example, take the equation of the line, y equals mx plus c. We now know the m value is 4.5, which we might just keep as 9 over 2 for the time being, x plus c. And to get the c value, which is the only other thing we need, that's this point here, we can just sub in one of our points. So let's say that we're going to sub in this one here, the point 4, 3. So we're going to let 4 be the x and 3 be the y. So if we put a 3 in here for y, if we put a 4 in there for x, it's going to be 9 over 2 times 4. Well, 4 times 9 is 36, over 2 is 18. So that's going to come out to be 18 plus c. Solving that for c, and we get 3 minus 18, which is minus 15. So that tells us that our equation is 9 over 2x, or you could write that as 4.5, but we'll go with 9 over 2, x minus 15. So our estimate about this maybe being around minus 12 is pretty good. So that came out actually to be minus 15, but that's the power of having that visual. Without that visual, I would have no idea if that was correct or if that was correct. That quick sketch makes a world of difference in these questions. So that's basically that one there. The third one's slightly different because what we've done here is we found exactly the equation of these lines. We know that that is the equation, 100% guaranteed, validated by the diagrams. This one, we don't have enough information to actually write the equation of the line. We don't have, for example, 2 points. It's really 2 points, of course, that define a line. If you've got 2 points, draw a line through them, then that is the line. You only need 2 points to make a line. Here we don't have any actual points. So this could be a question where it might be part of a larger question. We're just trying to estimate the equation of a line. So let's just go back to what the equation of a line is. Well, it's mx plus c. There's the 2 parts that define that, the m, the gradient, and the c, the y-intercept. So let's just think about these. Well, let's start with the y-intercept. So the only reference we've got is this 10 point up here. So we can just use that as a guide. So if that's 10, then that there would be, say, 5. That seems to be about halfway up to 5, so looks to be around 2.5, okay? So we know that the c value is around 2.5, or you could write that as 5 over 2. Doesn't really matter, 2.5, 5 over 2, same thing. The gradient value, we could try and estimate a couple of points and then work out the gradient using the formula. So we could, for example, using the scale, well, we've just decided that that point there is at 2.5. We could use that scale to say, well, if that's 5, that's kind of close to 5, so maybe that point would be at negative 5. Then we've got 2 points, and we could use that to get the gradient. That would be one way. Another way would be to say, well, this looks to be close-ish to 45 degrees, maybe a little less than 45. And a gradient of 1, an m value of 1, that is equivalent to a 45-degree line. So this is probably something a little less than 45, so a little less than 1. So we could maybe estimate the gradient to be 0.8, 0.9, something like that. Just a little bit less than 1, but not significantly less than 1. So let's just maybe say it's 0.8x plus 2.5. So that would give us a reasonable estimate. If we did go with the points, then this point here is at 2.5. 0, no it's not, it's at 0, 2.5. Oh, got to get your x and your y coordinates the correct way around. So let me try that again. This point is at 0, 2.5. And this point we're guesstimating to be at minus 5, 0. So we could just go ahead and try and work out the gradient from those points. So if we call that x1, y1, x2, y2. Now remember, everything here is an estimate. So we're just hoping that this number, when we run through this process here, comes out to be something close to 0.8. Doesn't matter if it's not 0.8, it's not going to be 0.8, I don't think, but it'll be close kind of to it. So it's going to make some space here. So using our formula for the gradient, so m equals y2 take away y1, so that's going to be 2.5 minus 0 divided by x2, which is 0 minus 5. Be careful with the double negatives there. So that gives us 2.5 on the numerator, and it gives us 0 minus 5, which is plus 5 on the denominator. So we've got 2.5 divided by 5. 5 is twice 2.5, so that comes out to be 1 over 2, which is 0.5. So that's pretty good. I'm pretty happy with that. So it really is, this is fine. This is just in the ballpark. Like we said, these were estimates. It could be that this number is correct and this one's wrong because I've estimated these points to be incorrect. But the whole point was that we're just exploring different methods to estimate the equation of this line. And we've used a second check there to kind of make sure that this number is close to what it should be. So these are the more formal methods for actually making the equation of the line, for writing that equation. This was more of an estimated approximation of what the line roughly might come out to be. So you might need this in some question types. This as part of answering the overall question. This would be a question in and of itself that you would be expected to answer entirely accurately. In fact, this is probably the most common question in straight lines. Basically, you're given 2 points on a line, either explicitly or kind of implicitly on a graph, and then you've got to actually make the equation of the line. But straight lines are a great topic to work and a difficult topic for the reason that they blend algebra and geometry. If you can align your algebra and geometry skills and bring them together to answer these questions successfully, then it shows that you're balancing between those two worlds really well. So a great topic to test out a bunch of skills, so definitely check out a few practice questions.